Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer question number 17 from the May-June 2018 Edexcel IGCSE Mathematics A paper 2H, higher paper, and this question here is about differentiation. So we're told that you have y equals x cubed minus 2x squared minus 15x plus 5, and we want to find dy dx. Now dy dx is when you differentiate y with respect to x. So we have to take these terms, and when we differentiate a power term, we multiply by the power and take 1 from the power. So you have 3 times 1x, so it's 3x, and take 1 from the power squared. And here you have minus, now 2 times 2 is 4, and then x to the power of 1. We don't really need to write the 1, I'll just write it for now. And then you have here minus 15x. What happens when you have something and the power isn't written there? Well, it means there's a 1 there. So you have 1 times minus 15, which is minus 15. And then this becomes x to the power of 0, which is just 1, so you don't need to write it down. So any time you have an x term without a power, it means x to the power of 1 there. It just drops to x. And a constant will just become 0, because if you think about this in terms of x, it's like 5x to the power of 0, and when you multiply the power, the whole thing becomes 0. So basically that is how you differentiate this. We don't need to write the 1 here in the power, so we can just write our answer in the space as 3x squared minus 4x and minus 15. So nice simple part A. Then part B, it says C is the curve with the equation y equals x cubed minus 2x squared minus 15x plus 5, which is exactly the same as what we differentiated. Work out the range of values for which C has a negative gradient. So basically what we have to do here is we have to find all the values for which the gradient 3x squared minus 4x minus 15. Before I go into that, the phrase dy dx, what does dy dx tell us? Dy dx is basically telling us the gradient of the function at any point that we want. Okay, so that's the gradient of the function. Okay, so we're going to find the range of values for which the curve C, the curve has a negative gradient. So we want to find the values of x for which dy dx is less than 0. Okay, for which it's less than 0. Now there's different ways we can do this, and probably the simplest way of doing this, probably for IGCSE students would probably just to be thinking about what the sketch of this graph looks like. We should understand that when we sketch a cubic curve, we can either have a shape that looks like this or a shape that looks like this. In general, that's generally how a cubic curve would be. If it looks like this, that's when the coefficient of x cubed is positive. When you have a positive x cubed coefficient. And when it looks like this, you have a negative x cubed coefficient. When it goes up and then up again, positive x cubed, down and then down again, negative x cubed. So obviously this is this type here. So we can see that this graph is going to have a negative gradient when it's falling. Then the gradient is negative when it's going this way. This is a positive gradient, this is a negative gradient. So we can see that between these values here, between the places where it turns, these 2 points, okay, between those values you're going to have a negative gradient. So we can see that this equation will have a negative gradient, or this graph will have a negative gradient between the 2 turning points. Okay, so what we need to do is we need to find where the turning points are. This is one turning point, this is the other turning point. So the turning points, okay, the stationary points or the turning points, the place where the curve turns, as we can see, if we drew tangents at those places, then the gradient would equal 0. So the turning points, dy dx is equal to 0. So we have to take our equation 3x squared minus 4x minus 15, and we have to equate that to 0. That will tell us the x values of those 2 turning points, and it's between those 2 x values that the curve is going to be falling, meaning it has a negative gradient. So how do we solve this equation? Well, this is a quadratic equation, and you have to show that you have factorized this. You can't just use your calculator function for this. You should show how you factorized it. Okay, so how do we factorize something like this? There's lots of different ways of doing it, splitting the middle term. I personally like to use my little window method, which some of you might find a bit strange, but it's basically a visual way of splitting the middle term. So I take the x squared term, write it in the top left hand corner. I take the constant term, including the sign, write it in the bottom right hand corner. And then I find the product of these two terms, that's negative 45x squared. Now I know that these two numbers here that go in these two places must give me the same product, but the sum of those two terms must be the same as this middle term here, which is minus 4x. So I've got to think of numbers that multiply to give me 45, but when I find the difference between them, I'm going to get 4, because the sum is negative, one is positive term and the other one is a negative term. So add them together, I'm going to get 4. That means basically the difference between those two numbers has to be 4. Okay, so if we think about that, or 4x, so we think about that, we got, think of different numbers that give us 45. We have 45 times 1, that doesn't help really. We have 3 times 15, that doesn't help. We have 5 times 9 is 45, that looks like it's going to work because the difference between them is 4. So I know it has to be a negative 4x, so I'll put plus 5x and minus 9x. Those two numbers, when I multiply them, give me the same product of those two, and when I add them I get negative 4x. I found the correct two terms that this middle term basically splits up into. Now I can take out a common factor from, for example, this line here. What's the common factor of 3x squared and minus 9x? Well, I can take out 3 and x as common, and then I know that this term here, when I multiply these two together, I have to get 3x squared, so that's going to be x. 3x times x is x squared. When I multiply this by that, I have to get negative 9x, so I have to have a minus sign, and 3x times minus 3 gives me minus 9x, so there's a minus 3 there. And when I multiply this term by this term, I have to get plus 5x, so it has to be positive, has to be a 5, so x times 5 is 5x, and we can make sure 5 times minus 3 must give us negative 15, so we can see that we're correct here. So we have 3x plus 5 as one factor, and x minus 3 as the other factor. Okay, and now we can go on to solve this by, first let's just check 3x squared minus 9x plus 5x, that's minus 4x and minus 15, so we know that we're correct. Now we can say either 3x plus 5 equals 0 or x minus 3 equals 0. So in this case 3x equals negative 5, so x equals negative 5 over 3 and x equals 3. Those are the two values where the gradient is 0. So of course the one that comes first is going to be this one, so that's when x equals negative 5 over 3, and this is the second one where x equals 3, okay, because this, the smaller one comes first here. So we can see that basically the curve goes like this. We can see that the turning points here, this is where x is minus 5 over 3, and this is where x equals 3. So we can say the x values between which the gradient is decreasing, okay, where it has a negative gradient, between minus 5 over 3 and 3. That's where the gradient will be negative. Okay, it will be negative gradient. At that point itself, it will have a 0 gradient. At that point itself, it will have a 0 gradient. So between those two values, it will have a negative gradient. At those points, it will be 0. Okay, so the answer is x is between 3 and minus 5 over 3. Those values of x, it has a negative gradient. There are other ways of doing this as well, in terms of you could make an inequality. Okay, we can solve the inequality given by this. All right, we could find the inequality. This represents the gradient of the curve. We could actually sketch this curve, which is sketching the gradient curve. But I think for cubic curves, this is probably the easier method to use. So you just have to understand what the cubic curve looks like, and what kind of shape it takes. So it looks this type of shape when you have a positive x cubed, has that type of shape when you have a negative x cubed. That's a positive x cubed, so it's going to be turning between, it's going to have a negative gradient between those 2 points. Okay, if it was a negative x cubed type of curve, its negative gradient would be between that value and after that value, before that value and after that value. But in this case, it's between these two values, and so there we have our answer. I hope that was clear. If you would like to see other questions from this particular paper, you can find them in the playlist, which will appear over here. I haven't answered all the questions. Those questions that people have asked me to answer, you find them in the playlist. If you find a question from this paper that you want me to answer, send a request on the channel and I will endeavor to do so. And here you can find a playlist which will be about differentiation from my Edexcel collection of IGCSE work, which will be at the moment quite empty. If you want to see my stuff from my Cambridge differentiation, you can find that in this playlist over here from IGCSE. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.